Okay, this video we will be continuing on the Don't Eat the Yellow Snow series. This is video 8. We are going to, in this video, create the score. So we're going to be bringing in the TrueType font module for SDL. So if you are just joining this video and you haven't done the other videos, you're going to want to download, or you're going to want to clone the Git repository from Programming Rainbow on GitHub, Yellow Snow C SDL2. And we will be working with the source code from the last video, which is the video 7 video. We will be you can delete the source folder and rename video 7 to source, or you can copy it in, or however you want to do it, but that's where we're going to be working with. We're going to be working from the source code from the last video. So we will be needing this brand new module that we're bringing in, so we're going to be making our score, but we're going to need TrueType font. So let's start with initializing and bringing in TrueType font. So the first thing we want to do is go into main. So we're going to need to add the TrueType font module. So it's going to be include, for me it's SDL2, SDL, and this is TTF.h. Okay, so while we're in here, let's set the font size that we're going to use. It will say, we'll call it font size, and it'll be 24. Okay, so that is importing the module. Now it's already in the makefile, so we don't need to add to the package config in the makefile. It's already there. All the modules are already there from the beginning. So what we need to do is we need to go to initialize. Okay, so we've initialized SDL2. We got the image module, we got the mixer module. So this one we are going to be pulling in the TTF module. Let's look at that real quick. So it's pretty basic. It's not taking any flags. It's just the function, and it's returning 0 or on success or 1 on failure. So we can just wrap that in an if statement. So we'll go if that's TTF. Okay. And we can just use one of these right here. Okay, so we'll call this TTF, and this will be TTF right here. Error initializing TTF, and let's shut it down in game. So in here, let's use the opposite, which would be TTF and then quit. Okay, let's test this out. I'm just gonna hit run. Okay, looks good so far. I don't see any problems. Okay, so we have initialized TTF. We do need to open a font, but we are going to open the font. We're not going to manage it inside game. We're going to manage it inside of the score module for the font specifically, because we're going to be needing to use it in that module. So what we're going to do is create some new files now. So we're going to need score.c and score.h. Okay, and score.c, let's go in there and do our header guard. There's our indif. Okay, right away, just like all the modules, we are pulling in game. Or, sorry, not game, main. That's a local, so we're pulling that in. Now for our module, we're going to have the exact same as everything else. We're going to have um, our new. We're going to have a new module. We're going to have a free, or sorry, a function that is creates our new. We're going to have a free function. We're going to have a reset. We're going to have an update, and we're going to have a draw. But this one, we're going to have a new one. We're going to have an increment. So like when we actually add to the score, we can just let that logic happen inside of this module. So we're going to have a function called increment. We need our struct. We're going to hold the render. It's going to hold its own image and manage it. This one's going to manage its own image this time. It's going to manage the TTF font inside of it. And it's also going to hold a color, a rect, and the actual score. So let's make that right now. We'll call this score. So we will be passing in a pointer to the render that is managed by game, but image and font will actually be managed locally here. So render. And we've got the SDL image. It's a texture. And we're going to have a TTF font. And this is going to be both image and font are going to be both on the heap, and we are managing them both. SDL color. This may be the first time we're seeing color, but color is literally just a struct of 4 1-byte numbers. Basically, it's from 0 to 255. It's red, green, and blue, and alpha channel. So it's RGBA. So it's just a simple struct. And same with rect. Rect is just a simple struct as well. And we're going to hold. So SDL has its own kind of internal. So we're going to use a uint32. This is just an unsigned 32-bit int. It's just the SDL, I think, has defined theirs internally. So I'm just using that. We're going to call it score. Okay, so that's our structure. Oops. So now let's make our function. So right away, bool needs new needs to be able to fail. So we got a bool, and we're going to go score new. We need to pass in our actual struct to score. The same way double pointers, because we're actually changing this pointer will actually be from game, so we need to pass in a pointer to the pointer so we can actually change the pointer. And then we need a render, so we can hold a local pointer to the render. That's so it can draw itself. So that will be our new void for our free function. But the same thing where we're doing the struct, the pointer to a pointer. And we need a reset. So the reset, we're actually going to be inside of this function, we're going to be dealing with creating textures and freeing textures and everything else, and those things can fail. So this is going to return a Boolean. Not like the flake and the player where we were just resetting some numbers. This one we actually have to generate textures that could possibly fail. So this one we need to be careful with. This one we don't need the pointer to pointer, so I'm just doing the S on it. We need an update, and the update as well, since we're dealing with a true type font, we're always kind of creating a surface and creating a texture. So this again, just like the reset, can fail. We have update, we have an increment and a draw. So the draw, we don't care about it failing, but the increment we do, because the increment is just running the update with a incremented number. It's just a wrap around it, so we do need the bool from that. But the draw, we don't. If it fails, it doesn't matter for us because that's happening 60 times a second, just the drawing of it on the render. So we can just use void on this one. Okay, so those are the functions that we will be using here. Let's make sure this is right here. Always forget this. So that is going to be our complete header file for score. I'm just going to grab these prototypes here. Let me just think about what I need outside all of these. Yeah, I need all of these out external. So now let's jump into our C. Right away, we're going to include the header file. Okay. And let's put our, right? And I can just set these up with the basic return, our default good case. Just so the compiler doesn't complain if we're trying to compile these as we're building it out. This is a return false. And this is just return. Okay, so with the basic skeleton, so this new function is going to look just like all the other new functions. So I can just grab the one, say, that's in player. It's going to look very much the same. This whole thing right here. The calc and all that is what I mean. Score, calc, struct, score. Okay, and we're checking if score is null. And if new score. Aaron calc of new score, return true. And now I want to create that local S pointer so I can just keep on working without dereferencing score every time. So struct score S equals the dereference of score. Okay, that lets me kind of do more stuff with score. So right away, let's link up the render. And we need the color. So we are just going to use white as the color. So I'm just going to make that right here in line. And yeah, I'm just going to cast the 4 numbers to it. So it's just going to be white and it's not going to be transparent. So it's all 2 5/5s for red, green, channel, blue, and alpha. So if you want your score text to be a different color, this is where you would change it. So that's setting our score up. So I'm actually going to create the font here inside of the inside of score, not in game. Game's not going to be holding on to the font, so I'm going to be managing it in score because I need to keep using the font here, and I don't want to keep passing it in to score. So since score needs to use the font over and over again every time the score changes or gets reset or incremented or anything, I need to use this font. So I'm going to create the font right here. So let's look at that real quick. So we have initialized it, we have quit the font or quit the TTF module, and this is TTF open font. So we need two things. We need the actual file to the font, the file location of a font that we're using, and I'll show it to you here in a second. And we also need the size, and this is what we set in main.h, the 24 font size. This is here. So this is a point size, not a pixel size. Just be aware of that. It's a point size, not pixel size. And this is returning a TTF font, but we already have this set in our score struct. So this is what we're going to be doing, and it's going to return a pointer to something on the heap. So we're going to check it the way that we always check that. And the way that we're going to close the font is here. And this is going to be done inside of our cleanup of our score module since we're holding this locally. Okay, so let's just do this. I'm gonna let it be its own thing. So we already have the font, the S font. It's right here. So it's going to be equal to this function. Now we are passing in the actual file. So where's this file? Well, over here in fonts, we have right here this free sans bold TTF. This is our font that we're using. This is the font that is used actually for Pygame by default, I think, and maybe Pygame 0, I'm not sure. Yeah, I think it's Pygame 0. I just use it everywhere as a quick, easy default. Fonts, and it's called Free Sans Bold TTF. So there's our font, and our size is going to be what we set in main.h, which is font size. Oops, size. Okay, and now we need to test whether font is actually coming back or not. So I could grab this right here. Say if S font. So if that doesn't exist, we have a problem. Okay, and I want to say, so open font. So error opening font. Font, say. And we need to get the error message from the font module. So we need the string. And then this is going to be TTF get error. That should get us the error. TTF get error. And then we're returning true out of this. So that is going to check to see if our font was created or not. We also kind of want to, I want this font to be in the top left-hand corner, but not all the way jammed in the corner. So I'm going to move it over 10 pixels by 10 pixels. So I'm going to set the rect that we're holding right now is all zeroed out. It doesn't have a width, a height, doesn't have an X or a Y. So I'm going to set the X and the Y to 10, both of them. And then the width and the height will actually be filled in later when we actually have a text surface or when we've actually created a surface. But we'll just leave these always at 10. So s.rect.y equals 10. So that'll just kind of, it'll be in the top left-hand corner still. And you got to remember this is the top left-hand corner of the font too, of the image. So if you were trying to put it in the right corner, then you have to do some maths because you got to take the width of the screen and then you got to subtract the width of the actual surface to do that. So it's quite easy just to throw it in the top left-hand corner because we are already dealing with the source of whatever image that we get is at the top left-hand corner as well. And we will be adding a reset function here, but since, well, we have created it, so we can already add it, yeah. Since we have already kind of, we already have the prototype for it, we can just add it in without the any errors. And this one we are checking if it errored, so it's in an if statement. It'll be our score reset. What this is going to do is whatever our score is going to set it back to 0, and then it's just a wrap around another function that is going to say to recreate the image that needs to be the font turned into an image that will be that score 0. You'll see it in a second here. So we're passing s in, and if it fails, we're just returning true. Because the failure, wherever the failure happens, we get the message right away. This is just returning the failure from this back up to this, and then continues all the way down the line. I just don't like where I'm looking at this. Yeah, there we go. It just looks weird to me. So that is kind of look like our whole function to create our new score. So let's start cleaning up this new score right away before we do anything else. So when we're testing anything, we can actually build it and let it clean itself up. So the freeing of this, first we need to make sure it actually exists. So we'll do that. And we got a dereference. If score, okay. So I am going to have to write this kind of dereference score over and over again. So I'm just going to make a local. I'm just going to make a local to it. Equals the dereference of score. Okay, so that just makes it a little bit easier for me to do things. So we do need to manage the closing the font and the texture that we're holding locally. So the font, let's look at that. We opened a font. To close a font, it's just closing the font. We just put the font in and it's a void function. So nothing major happening here. Okay, and the font is S font. Oops. Okay, so that closes the font. We can set the that to null. And we can destroy the texture the way that we always destroy textures with SDL destroy texture. And that will be S image. We'll set that to null. Okay, what else do we have to destroy? We also have the render we can set to null. We don't destroy it here, but we can set it to null. Let's look at H real quick and see what we have. We got the render, we have the image, we have the font. That's everything. Looks good. Oops. So now we need to actually destroy or free the memory for this So we can free S. We can set S to, even though S is going to go to scope, we can set it to null. And we also can set score that's being held by the game rect. We can set it. And that should take care of the cleaning up. Let's just go through it again, where we are making sure score even exists and has, making sure that struct was even instanced before we try to clean anything up. And then we are making a local pointer to it. And then we are cleaning up the font. We are cleaning up the image. We're setting the render to null. We are freeing its memory. We're setting that to null. And then we're freeing the original pointer to it that's being held in the game struct. Okay, and we don't need this. This is not right. Okay, so S equals null. Okay, so that is the freeing of this. Okay, the drawing is pretty straightforward. It's just like the drawing of the other ones. We are just going to do SDL render copy. And we need the render, which is sRender. We need the image. Our source rect will be null, so it's using the entire image. And our destination rect will be the rect that we are holding. And we need the address of that. So that is pretty simple for the drawing. The increment, the reset. So all reset's going to do is it's going to reset the score that's being held to 0 and then call the update function. So that is really simple. But it is going to pass on the error. Both increment and reset are just wrappers around update. And so they need to propagate updates error back. So we can say if first we are resetting the score. So the S score equals 0. And then we'll say if score update, and then we'll just return that. And if not, we return false. So if score update has failed, now we're going to return the failure out of here. Wherever this was going to be called, we'll understand that it's failed, and so on and so forth. So this exact thing is going to be the same thing that we're doing in increment. Right? We're doing the exact same thing here, except we need to increment the score. So we're going to say plus plus. That's double plus. So that takes care of those two. Okay, we have some here. We have to kind of generate what the score is going to be, so it's a little bit more interesting. But let's just see if this compiles. We're in score H. I don't think anything's going wrong here. Let's see if we can just run this before we get too far. We got an unused. What's the unused? It's this one. Okay. Maybe we can't. Score. I'm just going to call the update from game. I'm going to call the update from game, even though it's not doing anything. Just so that we can compile this. So where we need to update is if we have a collision with a white and a collision. If it's white, we are updating the score. So we can just put it here. Flake reset. We'll say, oh, we don't have access to this here yet. So in H, we need to bring in score.h. So, and that's in game H. Now we can go back to game. This is not where it was. Right here, we'll just do the increment here. We'll say, yeah, we'll say inc. That will make the update call. So that'd be score increment, and this will be G score. And we do need to check if this failed. So okay, no member name score. Yeah, because we haven't done it yet, did we? Okay, I thought we did, but maybe we didn't. Let's go to game. Game.h, and we need the score here. Okay, and then we need to also, in game C, we need to create the score. Okay, so we can do that. We can do it just like the other ones, just like this one here. We just do the same thing down here. So say if score new, and we have the address to the score. And then we have the render that we need to put in. So we're making the new score, and if it fails, we are just propagating that. So we return true. That should link that up. Okay, unused. Score update. How is score update? I'm definitely using it. I'm going to remove this from here. And I'm going to put it in score C because I don't need access to that. Maybe that'll make it stop complaining. Why do I have main here? My LSP does this quite often. It adds in on its own stuff that doesn't need to be there. Oh, it's just complaining because I'm not doing this. So I'm just going to do that trick. I'm just going to cast it to void. Just so I can get past this. I could use the less strict compiler rule, but I don't really want to. I want it to be strict. So I'm just going to go down here because basically it's like, you're not really using it, are you? And so we'll just let it think that we're really using it, but we're not. I'm just not doing anything, just nonsense. Okay. So that means all that stuff was working. Let's see what's going on here, if this is a kind of a false positive or a real thing. This is the calloc, I believe. Pretty sure we freed it, but maybe... Oh, I know why. We are not freeing it, because this is why it's important that we have all this. That's why I didn't want to disable the compiler, so when I make mistakes like this, I can know right away. So in game, we're not telling score to clean itself. Not main, game. So it is good to have those strict. So right here, we're cleaning up everything, but we need to add score free here. So and that's G. Okay. And now we don't get the... That was the sanitizer. Let's show it again real quick. So if I this is commented out, the calloc happens in score, so it's put on the heap, but it never gets cleaned up because the score free that does all the stuff to clean itself up, it never gets called. So if we check this out, this doesn't work in Windows, but I don't know if it works in OS X, but in Linux we can use this fsanitize address and the fsanitize address use after scope. We can use these to, let us know a little bit if we have a memory leak going on. So if I run this now, it runs just fine. But when I close it, it tells me that I didn't really free all the memory. See that? And it tells me what's going on too. If I look at the top here, it's telling me it happened in score 6. And that is where I did the calloc. Right there. So if I go back to score, right? The 6th line down, this is the calloc. This is us putting the memory in the heap. So it's nice to have that strict. That's why I didn't want to bypass it, because it catches my mistakes, which is really nice. So so in game C, we need to make sure that that is doing what it's supposed to be doing. There we go. Okay, so this is all set up. Now we need to actually start making a font. Or not making a font, but making an image that we can see. We have a font, but we don't actually have text on an image yet. So let's look at that real quick. We've initialized the font, we've closed the font, we've opened the font, we've closed the font. Now we need to render. We need to render something to a surface, and then convert that surface to a texture. So this is TTF render text blend. The blend is like, so we have nice anti-alias curves and stuff, and it doesn't look pixelated. And it's returning a surface. Okay, so we need the font that we're holding on to. We called it S font. And we need some kind of text, and then we need the color. And we're holding that color already as SDL, S color. So we have these two guys already. We don't have this text right here. And this is going to be a little bit tricky, because what's going to happen here is I need the text, but I need it from the score. So I need to convert the integer that, or the unsigned int that I'm using. I need to convert that to a string, but I need to know how big that string's going to be. And I also want to write score colon space and then have that number there. So since I don't know how big this is going to be, I don't know how big the array that to hold this string needs to be. Okay, and you can kind of make an array and put like 20 or something like that, but that's kind of where segmentation faults come in, because what if your array exceeds that size? So I prefer to do it dynamically, and what I'm going to do is I'm going to use the snprintf. I'm going to use snprintf right here. I know it's very white. This page is very white, but down here there's this kind of null sn printf, let's say null, yeah. So if we pass null in, and so we're not actually filling up an array, and we have 0, and we have our kind of our string that we want to happen, we actually get back the size of our that our string would be. So it's kind of like a test. It's like, what if I wanted a string this big? How big would that string be? Now I know how big that string is. I'm going to create a buffer, an array, character array, with that. And then I'm going to now fill in that buffer with with the string that I want. So it's a bit strange, but this is C, and C is a little bit difficult to work with strings. But I don't like to have a 20 character buffer or 50 character buffer, because to me that sounds like a bug. It sounds like a bug waiting to happen. That's what it sounds like to me. So I'm going to do it this way, and I'm also going to use that to allow the conversion of the integer to a string. Okay, so let's just start creating it. This is going to be in the update function of string, or score, I mean. So we have score, we have update here. Okay, we can get rid of this. And now this is all the stuff that can fail, so that's why everything here is a Boolean. The very first thing I want to do is I want to make sure that an image, if an image already exists, we're going to create a texture, an SDL texture, and I want to delete that texture. If that texture already exists, I want to get rid of it, because I'm going to make a new texture, and I don't want to. This would be a memory leak. This would be me making a new texture every time the score goes up, and it being on the heap somewhere. So I want to make sure that that if I already have a texture, I want to get rid of it. So I'm going to say if simage, okay, we're going to destroy it if it's here, because we're making a new, this update function is making a new image, so I got to destroy the other one. Destroy texture, and it'll be called simage. Okay, and I will set it to null as well, just so we're not holding on to the old, so we don't have that dangling pointer. Okay, so I'm doing this right away in the function. So if it doesn't exist, nothing happens. But if it does exist, now it's null. Okay, and now the next thing I want to do is, I said get the size of the buffer that I need to create. So this is going to be int, and I'm going to call it length. Okay, and we're going to use sn printf, and I'm not putting a length in, and I'm not trying to fill up a buffer with it. I'm not putting a buffer in. The buffer's null, and I'm not putting a length in. And sn printf is going to give me back the size of the string that would have been there, So this is the string that I want to create, but I don't know how big it's going to be. So it's going to be score. I want it to say score, and then I want it to actually have the score, which is the unsigned int that I'm using. Okay. And then, yeah, we're just s score. And this is going to give me the length of what it is, but I also need that null character. So I'm going to add one to this right away. Okay. +1. So this is going to be the actual size of the array that I need. The buffer, or whatever you want to call it. This is to make this string that says score and then has some number that I don't know what it will be. This is going to give me the length back. Okay. So now I can create that buffer, and this is just on the stack. This is going to go out of scope. This is automatic. My mind is slipping, but it's automatically handled by the scope of this function. So we'll call it score string, str. That's good. So our score string, and this is going to be an array, and the size of this array is going to be the length. Okay, so now we have the size that we want. Now we can almost use this same function above here. Right? Oops. We can just do that. Nope, nope, not that. That. Okay. So right now we want to put this, it needs to be our buffer. Okay, which is the score str. Now this is going to be our length. Okay, and it's probably going to complain about this length because snprintf wants size t as this number here, but it sends back an int here as far as I know. Let's check this out. Let's see here. Oh, it does give back a size t, does it? No, no, no. No, it gives back an int, but it needs a size t. Yeah, so we need to cast this. So what's going to happen here? What's going to happen here when I try to compile this with my strict compiling stuff is it's going to complain right here because this is an int, and it's going to be like, nope, I don't like that. It needs to be a size t. So we'll just cast it there. I already know that's going to happen. So this is going to give us, all this work just gave us the string that we want that is going to have score and whatever the number that our score is. So now we have this populated with this string, okay? What we need to do is we need to make this into a surface now. I'm just going to create the surface variable right here. I do not need to hold it. It's going to be temporary. It's going to go right away. It's, we're going to free it right away. So, and we can just call this, we can call it surface because there's nothing else is going to be called this. And then we're going to use that function that we talked about over here as a white screen. This TTF render blend right here. And we need the font, the text, and the color. So we already have all those things, font, text, color. So our font is S font. Our text is score str, score string, and our color is S color that we've already set up. And now we need to check if this surface was made or not. So let's see where we can grab an error message from. This looks like a good place. So we need to make sure that this was, that's why we had that, this is a bool. Now we see because we got this stuff going on here. So was our surface made? What should we say? Error rendering text? No, not rendering. Creating text surface. Error creating text surface. And this is going to be a TTF error, yes. Okay, so error creating text surface. So now if we do have it, we need to convert this surface to a to a texture. So I'm not sure if I have that here. Do I have it? Yeah. So create texture from surface. So this is going to take the render and this is going to take the surface and it's going to return a texture. So we take the render, and we need to take the surface. It's called surface. Okay. And this is returning our S image. That's why we needed to make sure it's up here, because if we just did this without destroying it up here, what would happen is the old image on the heap would still be there, but we'd lose the pointer to it. The new image being put on the heap would now, the pointer would be held here in our image, and every time we did this, if we did it 10 times, we would have 10 images on the heap, but we'd have only a pointer to our first image. So that's why I'm destroying it here first and setting it to null. Now, if this fails, this is supposed to send me back null. If it didn't, but even if it does nothing, it was already set to null here. So we have our S image, same deal. Now we need to check the same thing if this has failed. So we got our image and creating texture from surface. And this is an SDL error because this is an SDL function right here. Okay, so we have this. Now the question is how do we best free this surface? Well, I think that I should actually free it before I even check to see if this, before I even do this check. Because if I free it after it and this check fails, then the surface isn't actually freed. So I'm going to free it first. So I'm going to consume this surface basically and then free it right away and then check if the texture was actually created. So I'm going to use a free, it's SDL, free surface, and it's just called surface. So this is the surface I'm creating here. I'm checking to make sure if it got created, and I'm creating the surface from whatever the string is, which is the score and the number. So that's the surface I'm creating. Now I'm converting this surface to a texture. I am freeing the surface right away. Now I'm dealing with whether this texture succeeded or failed. That is all correct. So the one thing that we're missing here is we need to populate we need to populate from this surface the x and the y. Okay, we can do an SDL query texture, or we can just take the surface right away, since we have the surface here, and we could just populate it here straight from the surface. So we could say s, and we don't have to worry about the querying failure. S rect width, yeah, that's right, equals surface dot w. So if we did it from the texture, we have to run a function that sends them in and it can fail and everything else. But this is just simple. This surface already has this information. Height. We're not setting x and y. That's already set to 10 and 10. H. Okay, so that will give us our populated width and height. So we know how to draw the, so our texture can draw it on the screen. I think that is it for this one. So let's clean that. Okay, so that should be our whole function. Hopefully I didn't make any major mistakes here. So we should see, we haven't told it to draw yet, but we should see score equals 0. I'm setting reset. So reset does, well, score always equals 0 anyway. So yeah, so we can start drawing this on the screen now. And there we go. We got some problems. Oh, this is, sorry. This is a pointer. Okay. I'm just going to compile this really quick, and then we won't see it yet, but then we will see it after this step. Okay. it all looks good and it's all free and good. Okay, so now let's make it appear on the screen. So we just need to go into game and tell it to draw itself. So right here in the drawing section, we're drawing the background, we're drawing the player, we're drawing the flakes. Let's draw the text or the score on top of everything. So if a flake comes through, we can still see the text. You could make it either way if you want, but we'll just do that. So we'll go score, draw. Oops. Okay. So now we should definitely see something in the top left corner. There we go. There's our score. Our score is 0. Oh, our score is 1. So we actually have, because we said it before, where it was incrementing when I was trying to, when it was saying I was not using the update, we had set that to try to bypass that. But let's go back and make that better now. So we are seeing our thing, everything's working. So the scoring is going to happen in the collision. So whenever we get a white, we're incrementing our score, and this can fail so that we are handling the true. We are passing that down if it did fail. In here, I don't want to reset. I don't want this. I want it on the reset of the game. So here's where I want to reset the score, because when I'll show you. Oops. So say you got some score and you're doing good on your game, and then you get a yellow flake. If we did this right away, this would zero out. And I don't want it to do that. I want it to keep showing you the score you had until you press the space bar. So when you press the space bar, then we're going to reset the score. But the score is going to stay. All the flakes will stay. So you can kind of see what happened, how far you got in the game. Everything still shows. So I'm not going to. I'm just going to close all these real quick and just get into game. So we do want it incrementing when we hit we want it incrementing here, but I do not want it resetting here. So what I'm going to do is it's going to be up here in the game. I'm going to do it here. Oops. So I'm going to say, and this is going to be something that can fail, so I'm going to wrap it. Score reset. This is a G score. So if this fails, we're just going to return true. Okay, so that is going to reset our score. So the other one is being incremented here. It is being reset here. Player, you can uncomment it if you want the player reset as well. Let's check it out. So we got some score going on. Okay, now I'll hit the yellow. Okay, so the score still shows, but now when I press space, all the flakes should reset. My player won't reset, but the score should reset back to 0. And there it goes. The score is 0. And yeah, that always resets it. Okay, so I think that might be a good place to leave it off. We are cleaning up everything. Let's just go back through it. So let's go to main H and initialize. We're not loading anything here. Go flake C, flake H. So in main H, we needed to add in our font size, and we also need to add in the module TTF font to get access to the this module. And I'm just putting this font size here, so if you want to change the font size, you can just change this number and recompile it. So in initialize, we need to initialize the TTF font, and there's no flags for this one, so it's just a simple thing. And then we're actually making the font in flakes. Where is it? Not flakes, sorry. Not flakes, score. So we're actually initializing the font here and holding it locally. And then we are cleaning up or closing the font here as well. And we are closing the game C. We are quitting the TTF here. We are first closing the score locally, which actually closes the font. But then we're quitting the TTF module here. Okay. And most of what's happening, here's the score H, we have these functions. We're holding a local pointer to the renderer, but we're actually holding our image and our font locally. So we are managing those inside of here. So our cleanup is going to be closing our font and nullifying it, and then destroying our texture and nullifying it, and nullifying our pointer and clearing itself. The update and the reset are just wrappers around, or sorry, not the update. The reset and the increment down here are just wrappers around this function here. They're just either incrementing the score or they're setting the score to 0, and then they're calling this guy, which is the one that's generating the image. It's going to create the string that we need. It's going to then create a surface for that string. It's going to get the width and height of that and store it in our rect. And it's going to convert that surface to a texture, free the surface, then check to make sure that surface was created or that texture was created. So that's why these are all booleans, and these things are all wrapped in returning false or true if they fail. Okay, so I hope that explains how to use this. We don't need these up here. My LSP loves sending them in. And that should be everything for this one. So that is the scoring, and that is the TTF library for SDL. This was explained in detail in the beginning, the beginner series for SDL and the C language. So this is just us building a game with it this time. So thanks for watching. Bye.